Okay, now we're on page 26 looking at these proofs. Given that RS is congruent to TU, problem 6, VS is congruent to VR, and angle RSV is congruent to UTV, I need to prove this is a rectangle. So first of all, let's go ahead and make our marks. RS here is congruent to TU, all right? VS is congruent to VR. Aha. Well, what does that mean? Well, and oh, I have another angle. RSV is congruent to UTV. Is that right? Yeah. Okay. Well, what I just proved, if this here is an isosceles triangle, right? So because you have two congruent sides, so this angle has to be congruent to that one by the base angle. I also know these two angles have to be congruent to each other because they are vertical angles. The other thing I know is that since it's, well, initially I was going to assume it was a parallelogram, so this is bisected. But let's see, I have angle, angle, side, which means corresponding parts of the triangle are congruent. So let's start with that again. We figured out that this is our given, that's our given, and we can say angle S is congruent to angle R because base angles are congruent in isosceles triangle, right? Triangle. Pretend I can write. And I know angle S, oh, and when I said S, I meant that S and I meant that R. SVR is congruent to angle UVT. And why is that? Well, vertical angles are congruent. All right. And I knew that these two sides were congruent by given, right? So I had these angles right here. I had that side. I had either one of the angles, right? And I had this angle, that angle. It was given to me in that side. Angle, angle, side means the triangles are congruent, which then, so triangle SVR is congruent to, and it doesn't matter which way you start because it's an isosceles triangle TVU by angle, angle, side, right? Sorry. Okay, angle, angle, side. Now that I know those are congruent, I can say that VT is congruent to VU. And that is because corresponding parts of congruent triangles are congruent. And since these are congruent and bisected, I can see that SU is congruent to RT. You could argue, okay, you could do angle addition postulate if you want to be particular. And maybe that's what I'll do, angle addition postulate. Okay? Which then means that basically I'm saying this plus this equals that times that, so I'm kind of doing some substitution. I'm going quickly through this. The diagonals are congruent, so that means that SRUT is a rectangle, and that's because diagonals are congruent. Okay. Next one. This one's a little easier. And by the way, there's more than one way to do some of these proofs. You might see a shortcut that didn't happen to occur to me, especially since I'm doing these on a Friday afternoon and everyone's gone. Okay, WX is congruent to ZY. WX is congruent to ZY. And we have XWY is congruent to ZYW. Okay, oh, I can see these are parallel, right? Alternate interior angles. Don't know if I need that. Then I can also see that angle XWY is congruent to XYW. Oh, that means that's isosceles. So that angle's congruent right there. This is bisected. Well, I've got two sides congruent, and I can actually get another side congruent to itself by reflexive property. So what I'm going to say is WY is congruent to WY by reflexive property of congruence, right? Everything's congruent to itself. Well, now I can see I have angle, side, oh, side, angle, side, side, angle, side. So triangle XWY is congruent to triangle ZYW by a side, angle, side. Which means, first of all, oh, I also know that XW is congruent to XY because that's definition of isosceles. See, I see these base angles are congruent. So notice how I'm kind of going out of order. That's okay. All right. Then this has to be congruent because of CPCTC to all the other ones. It doesn't matter which one you pick. WZ is congruent to ZY, or better yet, XY. And I'm going to say CPCTC. It's better to have them be from different parts of the triangle, corresponding parts of the triangle. All right? Which means all four sides are congruent, so this is a rhombus. XWXYZ is a rhombus. Little room. And that's because all four sides are congruent. Okay, now this one on the kite, this is an interesting one. They say ID bisects RB. All right, so that means this is equal to that. And they also tell me that BI is congruent to IR. Well, the main thing that tells me is that this line is a perpendicular bisector. Because the way we construct perpendicular bisectors, if you do a circle here and a circle there, all these points are equidistant from point B and R. Well, I don't want to say they're halfway between, but this distance is the same as that one. If I did a point here, those distances would be the same. The only problem I have with this problem is they didn't really give me enough information here. Technically, this could also be a rhombus if these were congruent to those. They didn't say. So it's either a kite or it is a rhombus. Those are the only two shapes you're going to form with a perpendicular bisector. So I would say these are perpendicular, right? So I know the diagonals are perpendicular. Well, actually, what I should say is ID is perpendicular to RB. Pretend that's an I and a D. Terrible handwriting today. ID is perpendicular to RB because ID is a perpendicular bisector. And that's because you know these distances are equidistant. So I'm going to kind of just definition of perpendicular bisector. When in doubt, do definition. All right, it's a good way to get sloppy. All right, since the diagonals are perpendicular, this is either technically a kite or a rhombus. So I'm a little on this one. So it's probably a kite because the odds of these being congruent to that, so many choices. So I'm going to say it's a kite or a rhombus. So I'm going to disagree that you can technically prove which one this is, unless they gave me something that I don't see that proves that's a different length than that. Okay, next one. We have ABCDE is a parallelogram. BC is the base of an isosceles triangle, BCD. So if that's the base, these are the legs, they're congruent, all right? And they tell you this is a parallelogram, right? So that tells you that angle's congruent, right? Which means that if that's a parallelogram, then I know this is parallel, right, to that. Then that means that these two are parallel. That's a corresponding angle with that. So I can say angle A is congruent to angle B because corresponding angles are congruent. Right? So because they gave me the fact that these are parallel lines, corresponding angles with parallel lines, I should say that, are congruent. All right. So and also because this is a parallelogram, by the way, I also know that this side is congruent to that. So I might have done an extra step I didn't need. See, these two are congruent. So AE is congruent to DC. Why? Because opposite sides of a parallelogram I'm going to just draw it. Ah, terrible parallelogram. Are congruent, right? Opposite sides are congruent. Then that means that congruence moves over there. Since AE is congruent to DC, and these two are parallel, and these two are not parallel, then this is an isosceles trapezoid. So ACDE is an isosceles trapezoid. I can't write. And the reason is ED is parallel to AB, and the legs, EA is congruent to DC, and they are not parallel. EA is not parallel to AB. That's sort of a given. All right? And let me go ahead and take a break. I'll do another video.